So I do record it. So this is why you don't play tennis also. Okay. So I'm going to keep going here with notes 3. You will very often be asked to describe a distribution. And this acronym SOX is how you should remember like the words that you use. So you're going to define the shape. And we will get into shape. So we'll basically break down all 4 of these topics. So the shape, outliers, center, and spread. For center, the word center doesn't actually mean anything. If I give you a list of numbers and say, tell me the center, that's a meaningless question. So don't ever say like the center is. You have 3 choices for center. You can use mean, median, or mode. The same thing with spread. Like the word spread doesn't mean anything. So like the spread is 12. Like I wouldn't know what that means. You have 3 choices for spread also. There's range, IQR, and standard deviation. So let's start with shape. So like you'll get a data set or a graph and it'll say like describe this data. So there is unimodal. Unimodal means like one peak, one hump, one mode. So it could be like this. It could be like this. It could be like that. But you've got like one peak that has like the most data at that spot. Bimodal, so bi means 2, so there's modal means like most. So there's 2 spots where there's the most. There's 2 humps, 2 bumps. So it could be like that. Like it might be symmetric like that. It might be something like this. A lot of tests, not a lot of tests, but some tests I give are kind of like this bottom one. So like the majority of the class gets, B, C, A up here, but then there's people that like that. This is not really an AP, more like a geometry or algebra. There's just a chunk of kids that they just get like 10%. So a lot of kids either fail or get an A, B, or C. There's not like a bunch of like D's. Just an example. Uniform is when it's pretty much flat. So all heights are approximately the same. So a histogram, for example, might look something like this. And it's not perfect, but we'd say like this is approximately uniform. That doesn't come up a ton in this class. But you should know what it's called. Think about like if I rolled a die and graphed like the number of 1s, 2s, 3s, 4s, 5s, and 6s, like they'd all be pretty much the same, right? Not identical as you went on, but like the number of 1s, 2s, 3s, 4s, 5s, 6s should all be similar as you roll, so that'd be a uniform distribution. Symmetric. So symmetric just means it's the same on both sides. So it can be like whatever, as long as it's the same on both sides. It could go like this. A uniform is symmetric. It could be bimodal, where it's like the same on both sides. Or it could be this like approximately normal, which is kind of what we work with the most in here. And that is symmetric. But symmetric doesn't mean that, because there's other things that can be symmetric. And then left skewed and right skewed. So left skewed, the tail is on the left. So it'll look like that. And then right skewed, the tail is on the right. Where it would look more like that. And we talked about this one. You can think of like income in the United States. So the majority of people are going to be down here. So these people are very poor. This might be like middle class. So most people are here. But then you got like Bill Gates and Bezos, and they're way out here. So it drags. Like a normal graph would kind of go like this. But it can't be normal because of the super rich people. So that takes this tail and like drags it out. Does that make sense, the difference there? Left and right. So try those next two. And if you want to do it like in pencil, because you're not sure, or like think about it before you draw, go ahead. But I want you to try to draw those the two things they're asking for there. This warm like downstairs and everywhere else too. It's freezing.
I like it.
You like this? Disgusting. My shirt's sweating.
Anybody who came from Packard, is it cold down there? Because this room's always cold. Really? Yeah.
It's pretty bad then. Alright, symmetric, bimodal. So symmetric means it has to match like left and right. Bimodal means there's two peaks. So I would have done probably something like this. You could have been like, I don't know, decided you were going to do a histogram. Maybe it looks something like that. So it's symmetric because it's the same on both sides, and you got those two peaks. Unimodal, so one peak, right skewed, which means right tail. You got one peak, and then there's a tail. They're there. Alright. Next thing is outliers. We don't really get into we can't really get into calculating this until we get to box plots. Elias Hop. So we're going to kind of skip outliers for now, and we'll come back to it. 3 measures of center. Yeah. I'm just mean, median, mode. I don't know that we need to do some giant activity for this. Let's just put some numbers in order. How many siblings do you have? I don't know. I'm going to say 0, 0, 1, 1, 1. 2, 2, what? Okay. A lot of 2s. I got this fan running right next to me, so. Let's just do that. Alas, that was for 130. Okay. So mean is the average, right? So what's the average of those? It's gonna be 1, isn't it? Because like these are all 1, and then like these two are they're not 1, but they're the same distance apart from 1, so it's symmetric. The median, you put them in order, and what do? You like start crossing until you get to the middle. So the median would also be 1. Look at this. So cross to middle. And then the mode is the one that happens the most. So the mode here would be 1. So that we did that the first day of class too, like the mean, median, mode worksheet. See, so it wasn't an icebreaker. I was previewing. Question on mean, median, or mode? Okay. so I'm gonna move past that then. And let's go to, well, yeah, we're kind of moving past it. So turn the page. So a student takes 7 exams and gets these scores. And some teachers might eliminate the outlier. Like, how many of you guys have teachers that grade, like, I'll drop your lowest test or your lowest quiz? So some teachers might not. So let's say you had these grades on your test. Did you have a question, Bussy? You were just. That dropped it. I thought there were a lot. Figure out the mean of this with and without the 0. So figure out the mean if the teacher dropped the lowest score, and figure out the mean if the teacher didn't drop the lowest score. So with that data set, if we cannot eliminate it, what's the mean? If we can eliminate it, what's the mean? So this one is 78.3. This one is 91.3. So when we eliminated it, the average obviously got higher. So what is that outlier doing to the mean? Bringing it down, dropping it, yeah. So that's called skewed left, because you got that super low x value. So then we get into this resistant and non-resistant. So non-resistant means it is strongly influenced by extreme values. So if I have extreme values, does the mean change? If I have 2, 3, 4, 5, 6, what's the mean? What's the average of them? 4. What's the median? 4. Well, now I'm going to change that to a 600. Did the mean just change? Yeah. It got a lot bigger, right? So that's non-resistant. Like, it can't resist changing when there's an outlier. But did the median change? Median's still 4. So the median is resistant because it resisted changing even though there was like an extreme outlier. Resistant and non-resistant. Range. Range. The range, if I change that from 6 to 600, will the range change? Do we know what range is? Biggest minus smallest. That's not. So if I change the 6 to 600, does the range change? Range change. It does. So is the range resistant or non-resistant? Non-resistant. Standard deviation. We might not be ready for this, but we're going to try. Standard deviation is how spread out the data is. So I changed that 6 to a 600. Did I change how spread out the data is? Yes, I made it like way more spread out, right? So is standard deviation resistant or non-resistant? It's non-resistant because it changed when I changed one of the values. This is all mean, median, mode stuff. Let's skip to, we're going to fast forward a little bit. Go to the top of the next page, summarize. So these are kind of the three that we use the most. Unimodal symmetric. Looks like this. This is approximately normal. We'll get into what that means probably like at the end of this week. And that means the mean is approximate. Doesn't have to be perfect, but it's like really close to the median and it's really close to the mode. Like they're all basically the same. And that's what we spend most of our time working with. So this is like I don't know, maybe SAT scores. So I think the mean of SAT is 1,000. So 1,000 would be the center, and then as I go further to the right, 1,200, 1,300, 1,400 happens less often. As I go more to the left, like 600, 500 happens less often as well. Most people are in the middle, and then the further you get from the middle, the less likely that is to happen. So left skewed, tails on the left, and that means that the mean is less than the median. So there's like extreme low values. And then there's right skewed, which is the opposite. That would be that the mean is greater than the median because you have extreme high values. All right, good there? So we did shape, we skipped outliers, we did center, and now we're doing spread. Three common measures of spread are IQR, standard deviation, and range. The range is the difference between the max and the min, the high and the low, top and bottom, whatever you want to say. Standard deviation talks about how spread out the data is. This worksheet has us go through a calculation to do it. You'll never have to calculate the standard deviation by hand in here. We can always use the calculator. And I don't want to get into doing it in the calculator yet, so for now we're going to skip that standard deviation part. But I do want you to know like what it is. So let's write it this way. Standard deviation equals the average distance from the mean. So like when I had 2, 3, 4, 5, 6 here, the mean is 4, and every point is like really close to 4. So you're gonna have a small standard deviation. If I do that, the mean's a little bigger. But these points are gonna be pretty close, and that point's gonna be really far away. So the average distance from the middle just shot way up because I made a number like way, way off to the side. So standard deviation gets like I think people think it's a lot more confusing than it is. It's just the average distance from the middle of all the points. So there's some like summary things you should know here. Skip that because we didn't do the pets thing. So I measured the typical distance of values from the mean. I was just saying. And then let's see if we can figure out these. So the standard deviation is always, and what they're looking for there is positive or negative. Oh, it's got to be positive, right? Because it's like a distance from the mean, so it's always positive. What would make the standard deviation 0? The average distance from the mean is nothing. Yeah. When what? So it's the average of all of the ones. So if it's the same numbers, is that what you're saying? Yeah, so if I had like 7, 7, 7, 7, 7, what's the average? 7. How far is that point from the middle? 0, 0, 0, 0, 0. What's the average of 0, 0, 0, 0, 0? Probably 0. So if you have a list of all the same numbers, standard deviation is 0. No, because it's distance. So like the positives and negatives don't cancel. If you look at the formula, what you do, so say it was like 3 and negative 3, you square them, which gets rid of the negativeness, so now it's 9, and then you add them up, and then you start working with it. So the positives and the negatives don't cancel. Standard deviation has the same units of measure. The standard deviation is, and what they're looking for there is resistant or non-resistant. Non-resistant. Meaning that a few outliers will make a change. They'll get bigger. And then the greater the standard deviation, the greater the variation. That's just another word. That's basically standard deviation squared. But it just means how spread out it is. Is that a question or a stretch? Alright, let's put this away and do like a data set thing with everybody. We're going to make a modified box plot. We don't do like regular box plots. All the box plots in here are modified. I want to know how many states you have set foot in. So count up how many states you have set foot in. Maybe we can do this like, try to put these in order as we go. How many states have you been in? You flew over it, it doesn't count. If you drove through it, but you got out to go to the bathroom, it counts. Your foot didn't hit the ground. 2 feet. Does that change things? Everybody got their number in their head? Not yet? Okay. What? Alright, we're going to try to do this where I can write them down in order. Otherwise, we have to like write them all down and then put them in order. So let's go through like number by number. How many have visited 0 states? Please, nobody raise. 1. Like just Michigan, anybody? 2. 3. 4. 5. 6. I got 4 6s, okay. 7. 8. 4 8s. 9. 2 9s. 10. 1 2 3 10s. 11. Alright, then I'm just going to be a jerk. I want an outlier in here, so I'm going to say like
25.
38. So that's our data set. We're good. So we are going to find, this is called a 5-number summary. We're going to find the min, Q1, median, Q3, and the max. So the min is just the min. That's 6. The max is just the max. That's 38. So median, we start crossing, right? So if I like work from the side, each side, and cross my way to the middle. This one came out to it, like it landed on a number. It's 8. What if it didn't? What if it came out to like I crossed off and I had an 8 there and a 10 there? You average them and you would use that. But this one came out to 8. So I can just write down that 8 because it landed right on. Now that 8 we've already like considered it. That is the middle. We've already written it down as the median. We used that data point. Cross it off. Q1 is the median of the bottom half. So you look at the numbers below the middle, below what you just crossed off, and find the median of those. Start crossing again. Maybe cross the other direction so you can tell what's going on. I got 6 there as well. Great. Okay. And then Q3 is the median of the upper half. So same deal, you're going to look at the top half of the data above that number, cross off, cross off, cross off, till you get to the middle. I got 10. Agreed? Alright, so in a small data set, it doesn't work out like perfectly. But what is really supposed to happen is 25% of the data is between the min and Q1. 25% of the data is between Q1. Q is quarter. Like you're splitting it into quarters. Quarter 1. The median is essentially Q2. We call it that. Between Q2 and Q3 is 25%, and between Q3 and the max is 25%. So that's a 5-number summary. Next, we're going to try to make a box plot. So to find a box plot, I need the IQR. IQR is the inner quartile range. It is just Q3 minus Q1. So this here, this distance here is your inner quartile range. So now our case here is 10 minus 6, which is 4. Alright, so now we're going to get into how to determine if something is an outlier. So outliers are either bigger than Q3 plus 1.5 times the IQR, why is it 1.5? Like, why is it double or triple? There's no magical reason. And different people will use different things, but the AP test is like, we need to have like a certain number that everyone uses the same, and they come up with 1.5. I mean, it's pretty common to use that one, but it doesn't have to be. It just has to be in the same place. Or smaller than Q1 minus 1.5 times the IQ. So let's figure out are there any numbers bigger than, so Q3, I'm gonna like basically use this formula. What's Q3? 10 plus 1.5 times, what's the IQR? Interquartile range? It's 4. So this is Q3 plus 1.5 times the IQR. So that's 16. Are there any data points bigger than 16? There are. If we only knew this, like let's say I don't know how many data points we have. I just give you this summary right here. How many data points are bigger than 16? 1 or at least 1? At least 1. Because I don't know what else is in here. If all I knew was this, I don't know, like, is there 11, is there 17, is there 18, is there 19, is there... So if I only know this, that's a trick they'll try to get you to fall for. At least 1, not 1. So we do have an outlier at 38. So we gotta check the other side also. Smaller than Q1 minus 1.5 times the IQR. So what's Q1? 6 minus 1.5 times the IQR is still 4. So that's 6 minus 6, which is 0. And you could not have visited less than 0 states. So there are no outliers. On the low end. Now we're going to make a box plot. Okay, so I'm going to use a number line for this one. You don't always have to, but it's just easier to explain. So let's start like this. So the median, I'm going to start with 8 is the median. 6 is Q1, and Q3 is 10. And those go in a little box. 6, 8, and 10. This is Q1. This is the median. And this is Q3. Like you guys saw these in summer work, right? It's not like I'm teaching something you've never seen before. Luke, did you finish summer work? No, boy. Show me something. Okay. Then there's what's called a whisker. There's not actually a whisker on this one, but you're going to put a whisker. Not a great example. Typically you have like a bar, like a line here, and then a bar. But there's not, like the min and Q1 are the same, so you don't do that. You'll see on the other side what it looks like. But this one just wouldn't have like the whisker. On the upper side, there is an outlier at 38, so we put that as an asterisk. So this is your outlier. And then the whisker goes on the biggest data point that's not an outlier. So look at our data set. Look at the list of numbers. What's the biggest data point that's not an outlier? 11. So that's your whisker. And this only has one whisker, so it's like a crooked smile. But this is the biggest non-outlier, and over here would be the smallest non-outlier. It's just the same, so it doesn't change anything. When you're making yours, you don't have to give me the words. You just give the numbers. I'm just trying to explain it, you know. And again, annoyingly, if you did all of that, you'd fail. Fail this graph. What am I forgetting? Labels. So I'll just put like number of states. Alright, I want to have you guys try one of those. So let's say, the data in here I can use. Yeah, there's one right in here. So if you look at this page, it gives you this data. How many hours of sleep they got before the first day of school. So that's the top page, that's the top of the page. You guys see where I'm looking, where the data set is? And then go through this next page. So you're going to find the 5-number summary, find the IQR. You're basically going to do what we just did, but with that sleep data. And I'm going to walk around and answer questions and make sure you guys are good and check your work. Yeah, I'm scared, Luke.
So like Friday and Monday, like I tried for like probably an hour just trying to get into the class because. So it says you're one of my teachers, but I've like gone to every single thing on Khan. Like this doesn't do anything. Like I'm just trying to get.
Did you use the link I sent you?
Yeah, I just couldn't get to the assignments in the class, so I'd go to this.
Click on that.
Yeah, and then I put in the class code.
You shouldn't have to. It should just like dump you into. Go ahead and go to Khan.
Yeah, and then.
You do have to. My bad. Okay.
Yeah, and I would put this code.
Okay.
I just got so like angry with it because I never could get in the class.
He was cut and paste. I thought you had it memorized for a second.
I have that part.
Pretty close.
Yes, because I tried it so many times. So I'd press join class. And then it would take me to this, but
I might
there's
know
no
why.
thing.
I just realized
And
because
I tried for like an hour. It made me so mad.
that is actually my fault, not yours. I'm sorry. It's because the due date is passed.
Oh.
So, can you click on assignments?
No, there's literally
There's nothing there.
Because like I thought I had too many classes already, so I deleted all my like old classes from last year and stuff, and like I don't know, it was making me so mad.
So you tried.
Yeah.
So I'll have to give you some more time, obviously.
Yeah. I tried like Friday and it didn't work, and I was like, I'll just give it a break for a little bit and try. I should have emailed you, but I thought emailing you would help.
It might have, because I might have figured this out, but I might not have. I'm going to put next Monday for the due date. Is that okay?
Yeah, thank you.
And then I just got to go through all these. But, like, make sure after I do this, reload it and make sure you can see the assignments. So you should have some now if you refresh. I'm not done because there's like more, but
they're like 70 or something.
Is that what it is?
That's what Leonard said.
Really?
He said they're easy assignments, so I could probably get through them pretty fast.
Okay. Yeah, that seems about right.
They're 70?
I think it's 61.
Okay.
Do you see them now, though?
No,
Are they like popping up?
I refreshed it, maybe.
What if you go to courses? Do I have to assign these to you now?
No, it's like, it kept popping up as like my old 7th grade course. Here, maybe I could like try and rejoin the class again. It says you're one of my teachers is the thing. Like it says you're my teacher.
Yeah, well that could be from like this class too though, because we joined.
Yeah.
There's both, right?
Well, I gotta rejoin that class too, because I ended up deleting, because I thought like that you could join the summer work class in that class, so that's why I couldn't find it. I don't even know. I tried everything.
Okay, it's not even here. Is this you?
Yeah.
Oh, okay. Is it MOR? It's like code?
Yeah.
Okay. No, they're not. It's not your fault. They're not assigned to you yet. So I have to do that.
So once I refresh, it should just like let me since I already put the code in and stuff.
You would think, but I don't think it's gonna work. I think
So I'll
it's
have
like
to re-put the code in. Or?
no. I think I have to do something.
Oh, okay.
So you're not. Don't worry about it until I tell you.
Okay.
Hey, it's ready because I can't fix it.
Okay. Sorry.
No, it's my fault, not yours. I'm sorry you spent so much time like trying.
I know.
Answers on the board. Yeah, it's not mine. This is like notes I bought. Thanks. I don't know why it says thanks. So don't just like check your answer, right? Just make sure you know how to do it. And what do you want? Put something up there. So you can definitely start the homework 3. It's basically what we just did. I don't know if you can do all of it yet, but you can definitely get started. So when you're done with this, if you got a question, please ask. Like ask up here or call me over. Whichever. But then I would go ahead and get started on the homework 3. So tomorrow I'll answer questions on that. And then we'll like finish this part, and I'll give you more time to finish the homework. Questions for me? It's a little different vibe than the class I had last year. Quiet, more serious students. It's the opposite. Felt bad for you last year. You were fine?
does it work?
You had like a study hall.
Yeah. 6 to 3.
I would, yeah. So I would use your time right now to start the homework. Remember the answers are on Schoology. I encourage you to check them. I want you to check them. Remember, if you want to be eligible for corrections, all of your homework has to be done. I'm not going to check it like day by day, but at the end I will.
If you want, you can just tell me in class tomorrow. Send me an email.
For your homework.
Yeah, whatever.
I got to figure it out. So there's like 61 assignments. I know I can go through each individual one and say, that take an hour, so let's see if it's a master to it.
There definitely probably is.
There's gotta be.
Yeah.